Okay guys, in this section 6-10, we're looking at the inverse trigonometric functions, and the first thing that we come to here is a table that kind of gives us the sketches of the graphs of inverse sine, inverse cosine, and inverse tangent. So inverse tangent and arctangent is the same thing. So you can either call it the inverse function, the arc function, or the inverse function. They mean the same thing. And so the first thing that you may notice when you come to this, the graphs of these, is they have a very restrictive range. All right, they've got a very restrictive range. And so let's just talk for a moment about why that's the case. Okay, so think about, let's say, the sine curve, right? Okay, now remember, when we're talking about inverse sine, that is going to be the inverse function to sine, right? And so remember, graphically speaking, to get the inverse graph, you reflect it through the line y equals x, right? And so the reason why the graph is so restrictive, and the range, I should say, is so restrictive, is because think about this graph right here. This graph is a function, passes the vertical line test all the way through, so sine is a function. Okay, no restrictions on the outputs no restrictions on the domains here at all, right? Now, if I take this and I turn it sideways, though, however, okay, this is not a function unless you restrict the range to half a period. Does that make sense? Because as soon as this comes back and goes back over itself, then it fails the vertical line test and it's not a function anymore, right? So that's why the range of the inverse functions is so very restrictive, because as soon as it doubles back over itself, it would not be a function. All right? So this is kind of flipped of what the graph actually should be, but you can see it here. Okay, so the range for inverse sine has to stop at pi over 2 and stop at negative pi over 2. Otherwise, it'll double back over itself, fail the vertical line test, and no longer be a function. All right, and likewise, the same idea happens when you are looking at cosine and arctangent, right? So again, the range has to be restricted only to the values that would yield a function. All right, so that's why they are restrictive. So this next table kind of gives you the values of each one of the inverse functions, along with the range and the domain. And so basically, the domains are the ranges of the original function, right? And the range, of course, is restricted by what would make the arc function an actual function. And so just to kind of give you an idea, for the range of inverse sine, that's from negative pi over 2 to pi over 2. So to get an idea of where that is on the unit circle, because we're going to be utilizing the unit circle to answer some questions over here. So from pi over 2 to negative pi over 2, then that would be the right half of the unit circle. From 0 to pi, that's the top half of the unit circle. And again, for tangent, the range for tangent, negative pi over 2 and pi over 2, again, is the right half of the circle, not including the endpoints this time. Inverse cotangent, from 0 to pi, again, the top half of the circle. For secant, the range is really from 0 to pi, but not including pi over 2. So it's the top half without pi over 2. And then the range for cosecant is from negative pi over 2 to pi over 2, but not including 0. So that's the right half of the unit circle, but not including 0. So the reason why it's important to understand what the range values are, what's an acceptable range for these inverse functions, is because on some of the problems that we're going to be looking at, okay, if you get an answer that's outside of the range, then you've got to throw that answer out. Okay, so that's kind of what we're getting at, and that's why it's important to make sure we understand what the range of those functions should be. All right. So the questions are going to ask us this, okay, to find the exact value of the expression. Okay, so when we want the exact value, then of course, you know, a rounded decimal is out of the question. And so you might say that the calculator is not completely useful here, but you can kind of cheat a little bit with the calculator, and I'll show you that in a minute with some of these problems. All right, so if I want the arctangent of negative square roots of 3. I want the arctangent of negative square roots of 3. Now, let's think about that in reverse. Remember, arctangent is the inverse function for tangent, so it undoes tangent. So thinking about it in that terms, when it asks you for an exact value, then you want to think about it like this. The tangent of what angle gives me negative square root of 3? That's what we want to think about. If we can figure out what the tangent of what angle gives me negative square root of 3, then I will know what the arctangent of negative square root of 3 is equal to. Because remember, they're inverse functions, right? So that's going to be my test. So I'm going to take my unit circle, and I'm going to see if I can figure out the tangent of what value that would yield a negative square root of 3. Now, let's go back to this. Okay, don't forget, having this or remembering this from the first section where it defines these trigonometric functions on the unit circle will come in handy. What's tangent? It's y over x. Okay, so when I look at this unit circle, first of all, okay, which side of the unit circle do I need to look on? Inverse tangent is going to be the right half of the circle. So I'm only looking on the right half of the unit circle to try to pick an angle that may yield us negative square roots of 3 when we take the tangent of it. Okay. Now, here's the other thing. I want to pick an angle that has square root of 3 at least as one of my points. Okay, so in other words, it doesn't make any sense to say that negative pi over 4 is the answer. I don't even want to try that because there's no square root of 3 in here at all. Okay, so I want to pick a candidate that has a square root of 3 in it, and of course it would be on the negative side since it's negative square root of 3 that I'm looking for. So it would be somewhere on this side, but remember these positive angle values match these negative angle values, so that's why I'm kind of looking right here to see. All right, now here's the other thing. Let's see. Remember, tangent is y over x. So I really want my square root of 3 to end up in the numerator, right? Not the denominator, because there's square root of 3 there in the numerator. So I really am looking for an angle whose y value of the point has a square root of 3 in it. So now that we've kind of narrowed it down to that, I'm going to eliminate the pi over 6, okay? And I'm going to try pi over 3 because there's a square root of 3 right here in this y value. All right? So I think that negative pi over 3 is probably a good candidate for an angle whose tangent would yield me negative square root of 3. So let's see if we can verify that that's the case. So let's go with tangent of negative pi over 3 and see what that, hopefully it gives me this. If it does, I'll know I have the right answer. All right, so let's see if it does. So negative pi over 3 would be here, right? And so that's going to be y over x, which is negative square root of 3 over 2 divided by 1 over 2. All right, so let's simplify that down. Let's see what we get. So I'll multiply by the reciprocal, so that's going to be negative square root of 3 over 2 times 2 over 1. And so that will cancel my 2's out, divided by 1, makes negative square root of 3, which is what I was hoping to get. So now I have verified that the arctangent of the negative square root of 3 is negative pi over 3. And I have my exact answer. All right? And the reason why I said that you can kind of cheat on these on the calculator a few minutes ago is this. So if I come up here now and I just put, if I go to degrees and I put in inverse tangent of negative square root of 3. Notice that gives me negative 60 degrees. And then I could just go back and say, well, what's negative 60 degrees? It's negative pi over 3. So on some of them, it works out like that, where the calculator can kind of help you verify your answer. All right? Just because of the fact that in degrees it does come out to be an even number, and you can go back and use the unit circle to see what degree measure that matches in radians, and then come up with the answer that way. I'd use that as a way to double check that you've done it correctly. All right, what about the next one? We have the arc cosine of negative 1/2, and we want to see what that's equal to. All right, so again, remember, your thought process here is working this backwards. So I want to see what angle whose cosine would give me negative 1/2. So the cosine of what angle would be negative 1/2. Now this is a little bit easier to identify than tangent, because what's cosine? Well, cosine is just equal to the x-coordinate. So really I'm just looking for an angle whose x-coordinate is negative 1/2. Now, keep the domain in mind, or excuse me, the range in mind. So cosine is going to be the top half of the circle for the range. Okay, so I just need to scan the top half of the unit circle, okay, for an x-coordinate that's negative 1/2. All right, so let's see if we can scan the unit circle for an x-coordinate that's negative 1/2. I found one here at 2 pi over 3, and so let's just plug it in and verify that that is correct. So the cosine of 2 pi over 3 is equal to the y-coordinate of the answer here, or excuse me, the x-coordinate, which is negative 1/2. And so I know that 2 pi over 3 is the correct answer. So the arc cosine of negative 1/2 is 2 pi over 3. Why? Because the cosine of 2 pi over 3 equals to negative 1/2. Remember, arc cosine and cosine are inverse functions. They undo each other. All right? What about the next one? Let's say I wanted to find the exact value of the inverse sine of square root of 3 over 2. Inverse sine of square root of 3 over 2. Okay, so again, remember your reverse thought process. I'm looking for the sine of what angle can equal square root of 3 over 2. The sine of what angle. Now, remember, start with your range values for inverse sine. Okay, it is the right half of the unit circle that I'm looking for an answer in. And so sine also, pretty simple, I'm just looking at y-coordinates. So I'm trying to find an angle whose y-coordinate is square root of 3 over 2. All right, so I'm looking for an angle on the right half of the unit circle, okay, whose y-coordinate is square root of 3 over 2. All right, and so y-coordinate square root of 3 over 2, pretty easily right there we can find that it's pi over 3. So what that means is I need to verify that the sine of pi over 3 and it is equal to square root of 3 over 2, and it is. So I know that pi over 3 is the correct answer. So anytime it's inverse cosine or inverse sine, okay, you're really just kind of looking for the correct either x or y coordinate, whichever one you're looking for. When it's tangent, it's a little more complicated because it's the y over x that you've got to verify the value of. So really the verification is more important when it's inverse tangent, more so than it is in inverse sine or inverse cosine, because you can just look and see that that's the answer pretty much. All right? Now, let's kick it up a notch. Let's say that we want to find the inverse tangent of the tangent of 11 pi over 6. Okay, now at first glance on this one, you might be saying, well, Coach, that's easy. The answer is 11 pi over 6, because remember, inverse tangent and tangent undo each other, right? So like, for example, if, what am I in here now? I'm in degrees, so I'll give an example in degrees. So if I did inverse tangent of the tangent of, let's say, 60 degrees, what do I get? I get 60. Why? Because these undo each other, right? The tangent of 60 takes this to some number, and then inverse tangent of that number takes it back to 60. They're inverses, right? Okay. But the answer here is not 11 pi over 6, okay? And you might be asking, well, Coach, well, why not? Why isn't the answer 11 pi over 6? Remember, we're dealing with inverse tangent, and with the inverse trig functions, we always have to consider is what is the possible range that we're looking at. So the range value can only exist between negative pi over 2 to pi over 2. And guess what? 11 pi over 6, okay, is not within that pi over 2 value, right? 11 pi over 6 is not within that pi over 2 value. Okay, so the question is, okay, how are we going to turn this angle into an angle that is within the range values? Because remember, these functions are periodic, so these angles, just repeat over and over every 2 pi radians, right? Okay, so they match up. So I need to see what angle 11 pi over 6 matches up with an angle that's within this range for the inverse tangent value, right? So I need to kind of subtract, well, I don't even need to subtract 2 pi off of this. Here's what I need to do. I can locate 11 pi over 6 on the unit circle, right, which is here around this way. But if I start here and come back negative, right, then what angle would that correspond to as a negative angle? Then that would be within the correct range. And so 11 pi over 6 corresponds to negative pi over 6 as a negative angle. And then so that's going to be my answer. Negative pi over 6, all right, is within the accepted range, right? And it's the angle that matches 11 pi over 6. All right, so with these types of problems, if you've got an angle that's outside of the range, then what you'll have to do is you'll have to say, okay, what angle does it match that is within my range? Okay. All right, let's see what we got here. So the next one is we want the inverse sine of the sine of 5 pi over 2. Okay, so once again, the answer is not going to be 5 pi over 2 for the same reason as the last one, because look at what the range for sine is. Once again, from negative pi over 2 to pi over 2. So what I need to do is I need to change this 5 pi over 2 to a value that is within the range. All right, so this time that value doesn't occur anywhere on the unit circle because it's more than 2 pi, as you can see. So what I can really do here is to get it within the range, the correct range, I can see what angle this corresponds to within the range by subtracting 2 pi from it. So what I need to do is I need to go 5 pi over 2 minus 2 pi, which I'll write as 4 pi over 2 in this case, just to make it easier. And so that would be pi over 2. All right. Now, pi over 2 was right at that border. This better be the one whose range includes it, and inverse sine does include pi over 2, so we're in good shape. All right. Now, if it was tangent, then it would not be included, but in sine, it is included in the range. Okay. So we're heavily relying on these, looking at these range values to make sure that the answer that we get is inside of the accepted range. Okay. All right, what about this last one now? Okay, so these are two different functions, right? So it's not the inverse of the same function, right? So it's not inverse tangent of tangent or inverse sine of sine. It's the inverse sine of the tangent of 5 pi over 4. Okay, so the first thing that I need to do here is I need to see what the value of the tangent of 5 pi over 4 is, and once I figure that out, then I can look for the inverse sine of that. Okay, so let's start off by doing this. Tangent of 5 pi over 4. All right, so let's go through and see what that's equal to. And so 5 pi over 4 is on my unit circle here at 225 degrees. Tangent is y over x, so that's going to be negative square root of 2 over 2 divided by negative square root of 2 over 2. So we got negative square root of 2 over 2 divided by negative square root of 2 over 2. And so I know right away that that's 1. And so the tangent of 5 pi over 4 is 1, which means I need to find the inverse sine of 1. Okay? So now, again, I'm in the mode of trying to figure out, okay, inverse sine of 1. That means I need to figure out which angle has a sine value of 1. So the sine of what angle gives me 1, in other words. The sine of what angle gives me 1. So once again, looking on my unit circle, remember sine is just the y value. Keep the range in consideration here. The range is from negative pi over 2 to pi over 2, or the right half of the circle. So is there anything on the right half of the unit circle, okay, that has a y value in the ordered pair of 1? And there is one angle that fits that criteria, and that's pi over 2. And then so that's your answer. So the sine of pi over 2 equals to 1. So that means pi over 2 is your answer. Alright, so there you go. That's your practice at finding the exact values for inverse trig functions.